channel. My name is Anna Tenbensel, and we are on day number 11 for this Juleetcode LeetCode situation for July. I have not really had a chance to look at this. However, I did just do number 23 in the LeetCode problem list, so this kind of feels like a similar vibe. So I'm hoping to kind of build off of that. So the day number 11 is problem number 863, all nodes distance k in binary tree. So let's jump into this question. So given the root of a binary tree, the value of a target node target and an integer k, return an array of the values of all nodes that have a distance of k from the target node. You can return the answer in any order. Okay, so I need to return an array of all nodes that have a distance k from the target node. And then can return it in any order. For binary tree, okay. I'm gonna look at these inputs here. And the output, the nodes and distance are 2 from the target node with a value of 5. Have values 7, 4, and 1. Okay, so the constraints, the number of nodes in the tree is in range from 1 to 500. That's the value. All values are node val are unique. Target is the value of one of the nodes in the tree. Okay, so given the root of a binary tree, the value of a target node, target, and an integer k. Okay. I kind of think I know how I want to start this. I don't really want to look at that yet, but I think, so what I think I would want to first do, specifically right here, is initialize an empty list for the results, and then also initialize a dictionary for the parent. So like there's like a parent node and then the child node. And then I think I want to do a recursive build parent function. So this is nothing like number 23. I was really hopeful. Because I want to take the node and its parent as an input for that. And if a node exists, then add the node to the value of the parent, to the parent dictionary. So let's start by writing those out. So I'm going to say result equals and parent equals, and I guess I'm going to make that a dictionary, didn't I? And then I want that to be a list. So yeah. So let's do that. Let's do a recursive function of build parent to populate that parent dictionary by doing a depth first search on the binary trees. Because we want to see depth, not breadth. So I'm going to say def build parent node are none. So then if the node takes the parent as an input, if node, parent node, parent, then so what am I trying to say? If the node exists, then it adds the node as the value and its parent as the key to the parent dictionary. Does that make sense? That makes sense. So we need to do build parent left, build parent right. Got it. Gosh, it's been one of those days, y'all. I said left and then build right. Just copy paste. Very nice. Okay. I feel like that makes sense. Hold on. Okay. Okay, I'm just going to leave that for now. We're going to pretend like that's fine. So then let's say build parent root. Okay, so now let's do the breadth first search, starting with the target node. So we're going to say def breadth first search of the node, and we want to do a couple things here, and I'm trying to figure out the order, the path of least resistance, if you will. I think we should do a queue. I'm going to write these out so I don't forget to do them. We should do a queue. We should do visited. And then we should do maybe a while if for, so while queue in the current distance. Okay, no, let me back this up. Build breadth first search is starting from the target node. It initializes that node distance. So we need to figure that out. Okay, so I think let's do set, not quite, set node. And then here, let's do collection EQ. And then let's go into that loop. So while Q current distance, should have been a, and then we should populate it on the left. And if, see, I still have to do the distance from K. Okay, so, okay, wait. Q, populate left. So, if the distance equals K, then the result, append current value. Oh my gosh. Current val. So for each iteration, it gets the node from the its distance from the queue using pop left. Hold on, I had an extra. thing in there. And then if the distance is equal to k, it means that the current node is the required distance from the target. So we can add that value to the result list. So then we need to iterate it over the left child and the right child, and the parent of the current node. So basically, if any of the neighbors exist, maybe, that haven't been visited before, they're going to be added to the queue, and then update the distance. Easy. Right. Okay, so for neighbor in current left, current right, and parent current, let's break them down. So if neighbor and neighbor not in visited, add neighbor. I don't know why I keep adding a T to neighbor, you guys. And then we update that queue. So then we say queue append. Neighbor. Oh my gosh, you guys. Distance plus 1. Okay. So at this point, this process continues until all of the nodes in distance k from the target node have been visited. Easy. I think that's right. Okay, so hold on. Let's go through this one more time. So make this make sense. We go over to the left child, we go over to the right child, and we go to the parent of the current node. And if none of those have been gone through, then we add those to the queue, right? And they get updated. They get the updated distance. And then it just continues until we get all the nodes at distance k from the target node that's been visited. Great day. That's right. So that should work. Oh wait, we have to. Breadth first search target. So that'll perform the breadth first search starting from the target, and then we return result. Does that work? Yeah. So we initiate that traversal, that breadth first search traversal, and then we populate the result list. And then it's going to be output as the distance k method. So let's run it. There's going to be a typo. I can already tell. My spatter stances are ding ding. Okay, wait. Let's review. Let's recap. Let's rehash. So these are wrong. Output is null. So something in here is wrong. Where are you? Where do you live? Okay. So parent node. Maybe did I get these confused, maybe? Maybe one should be the dictionary and the other one should be the list? Does that seem right? No, that's not right. That is right. So, hold on. So we build the parent, perform this whole depth first search situation. We build it, we did the breadth first search, we initialize the queue, keep track of the visited ones. Forgot to put an S. If that threw it off, though, I'm going to be so mad. Okay, so while queue is current, So this one's if the distance is equal to k. I think I might have just been missing that s, but I might be wrong. We're just going to run it, because if I'm missing an s and it starts to work, then it's still wrong. Okay, that makes me actually feel better about missing that. Okay. So we have, maybe it's here. Maybe it's here where I'm wrong. Because we're looking at the left, and we're looking at the right, and we're looking at the parent. Because that would be parent left, right. Parent left, right. Append the current value. This part I know is at least right. This I could change, I think. Initialize. This I know also is right. I could move this. Oh, interesting. Wait, bro. Okay, visited is not defined. Visited is not. Oh, I swear, you guys, this is going. Okay, global name visited. Visited. If I'm making sure everything's spelled right. Sometimes I stare at things for too long. So for neighbor. What did it say? Visited is not defined. How is visited not defined? I'm gonna throw things. You guys, it was the I. It was the I in visited. Yo, I gotta get better. I gotta do my Wordle more. But that doesn't mean anything unless we submit it. And amazing. Okay, it's not my best, obviously. Okay, so that makes sense. Just spell everything correctly, I guess. Also, I think that formatting didn't help. But, okay, cool. So I will leave this here. I don't really think I need to go through other people's solutions today, just because I don't want to take up too much time. But I also have to make dinner, so I will come back and or try to hash another one of these out. But thank you for joining me on day 11 for 863, problem number 863. I will post this in my GitHub. Feel free to clone and fork, do whatever you want to do. Make it better, make it worse, make it however you want, make it your way. Hashtag Burger King. Just have fun doing it, learn something, try something new, maybe take a different approach to something that you haven't done before. So I will see you guys in the next video. Thank you guys so much for watching.